whiplash, 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 one look give 'em whiplash.
Each node labeled from 0 to n minus 1 that is represented by array graph. It's an integer
튜닝 맞춰볼까 하나의 인정 기준에 맞춰 나의 세븐틴의 스케일을 쳐 아무래도 조금 특이해도 북을 치고 줄을 튕겨 따따라따따라따따라따 상관없이 이게 클래식과 new 땡또 새로운 조합은 우리 자랑이니까 멜로디.
Okay, a node is a terminal node if there are no outgoing edges, and a node is a safe node if every possible path starting from that node leads to a terminal node. Return an array containing of all safe nodes of the graph. The answer should be sorted in ascending order. Okay, so we are given with a graph of nodes 3, basically it means 0 will go to 1 comma 2, node 1 goes to 2 comma 3, node 2 goes to 5, node 3 goes to 0, node 4 goes to 5, node 5, and node 6 has no outgoing nodes. Okay, so if we draw a graph based on it, then it's let's take 0, 1, 2, 3, 4, 5, and 6. 0 to 1 there is a path, 1 to 2 there is a path, 1 to 2 there is a path, and 1 to 3 there is a path, 2 to 5 there is a path, 3 to 0 there is a path, 4 to 5 there is a path. These both have wait. Okay, these both have no outgoing edges, and this node has no incoming edges. Okay, what a node is a terminal node if there are no outgoing edges. Let me use other. Okay. You know what? Let me decrease font. Okay, this should be fine. Terminal node. A node is a terminal node if there are no outgoing edges. Here if we take which nodes have no outgoing edges, 5 and 6 have no outgoing edges. So these are terminal nodes. What are safe nodes? If every possible path starting from a node leads to a terminal node. So every possible path that leads to a terminal node. And we are supposed to return all an array containing all the safe nodes of the graph. Answer should be sorted in ascending order. Okay, if we take this example from as we discussed, node 4 and 5 are terminal nodes and there are no outgoing edges from either of them. And now paths from let us take should we go for some other color? Let's take this one. Okay, so if we take from node 0 we have path to 1 and 2, and from 2 we have a path to node 5 which is a terminal node. So what will be our path from 0 to be 0? Let me just think. Okay, so from 0 I always forget to reduce the thickness of the mount. So 0 to 1, 1 to 2, 2 to 5, or 0 to 2, 2 to 5 for node 0. Coming to node 1, but here I guess 0 to 1, 1 to 3 doesn't lead to the terminal. Doesn't lead to terminal node. So maybe we can't consider this. I think we can't consider this as safe node because they said all the paths going from that particular node is supposed to reach the terminal node. But if we go like this, 0 to 1 and 1 to 3, then it will again go to 0, but it won't come to node 5 or node 6. So then if we go to node 1, the same scenario, it will fail again because 1 to 3 goes back to 0 and that will come back to n and it will be a loop. Not reaching terminal node. Now if we go to node 2, so even this can be considered as a sort. Node 2, outgoing paths from node 2 is, it has only one outgoing path and that is from 2 to 5. So this is a safe node. This is a safe node. Now coming to node 3. Node 3 has only outgoing path and it goes to 0. So 3 to 0, not a safe state. So it's not a safe state. Then going to node 4, it has only outgoing path and it is going to 5. So it is a safe state. Coming to 5 and 6, both of them are terminal nodes. So all the terminal nodes, according to what we heard, safe states are the states where the outgoing nodes will always lead to a terminal node. Here, as these both are terminal nodes, we can consider these as safe nodes. So here, the safe nodes are 2, 4, 5, and 6. Now, how are we gonna figure this out? Now, how are we gonna figure this out? Let us think. I think we are supposed to use topology concept, but I'm quite not understand how are we gonna use topology concept. So for explaining, let me tell you what exactly is topology topic. Topology basically means that if there is an edge from U to V in a directed graph, a cyclic directed graph, then node U must be already visited for visiting node V. Let me go to this driver article to understand how exactly are we gonna use this topology concept. Where is graphs? Okay. and we have topo concepts. Okay, here we go. Yeah, this one I said right. That's the reason the node 0 can't be like this path can't lead to a terminal node, so node 0 is not a safe node. Okay, the intuition is to figure out the nodes which are neither part of a cycle nor connected to a cycle. Okay, so here we did figure out that this path was leading to a cycle. So nodes 0, 1 and 3 were not considered. Okay, basic intuition is removing. That are neither the part of a cycle nor connected to a cycle. Okay. One thing about toposalt is that it removes nodes that are part of cycle. For suppose, let us take this graph. 0, 1, 2, 3, 5, 8, 4, 6, 7, 9, 10, and 11. What topological does is it carries yeah, it carries an integrity vector of all the nodes. For suppose this is 1, 2, let us take 0, comma 0. How do we okay. Let us take it as 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now, in nodes for 0 is 0. In nodes for 1 is from node 8 and from node 0, so it's 2. In nodes from node to node 2 is from node 1, so it's gonna be 1. In nodes for in degree for node 3 is one node is coming, one edge is coming from 2 and one, okay, it's only one edge. So it's gonna be 1. For node 4, it's gonna be 2. Node 5 gonna be 1. Node 6 gonna be 2. Node 7 gonna be 1. Node 8 has no node, so it's gonna be 0. Node 9 is gonna have 2. Node 10 is gonna have 1, and node 11 has no integers. Okay, so what topology does is it pushes. I'm so sorry, my straight line diagram is so bad, but it considers this as a cube. So what it does is it pushes node 0. It pushes almost all the nodes which has in degree as 0. So node 0, node 8, and node 11. Now when it pops this out, it reduces the removes the edges from node 0. So from node 0, where do we have an edge? It goes to 1. So this will be converted to 1. And then we still don't have any edge, any nodes which has in degree as 0, which is not pushed into the queue. So then we'll go to next element and we'll pop this out. While popping this out, we'll repeat the same thing. So the outgoing edges from 8 is 9 and 10. So 0 and 1. Now since we have node 10 which has in degree as 0, so we're gonna push 10 into the stack. Q, sorry. Then we're gonna pop node 11, and we have only one outgoing edge from node 11, which is to 9. Sorry. Okay. So now we're gonna push node 9 into the queue, and then we're gonna pop node 10, which has no outgoing edges, and then we're gonna pop 9, which also has no outgoing edges. Now the queue is empty, and now the queue is empty, and toposort of 0, 8, 11, 10, and 9. You see, we didn't consider node these nodes, and this node and this node. These nodes are not considered because these forms a cycle, and these nodes are not considered because this node is related to, it's connected to the cycle. And why are these nodes are not connected? Because even this node is connected to cycle, and this node wait, sorry. Wait, I was supposed to. I'm so sorry, I made a blunder. Yeah, I made a blunder. Never mind. So yeah, 1 has an edge going from 8 and 0. So I was cut it out after we popped out this. So it's gonna be 0, and we're gonna push 1 inside. Okay. That's what I was thinking. This is here. It was supposed to. Okay, never mind. Node 2 and node 1. So yeah. Okay. Now if we pop node 1, node 1 has an edge going to 2. So this would be cancelled out to 0. The whole thing would be changed. So yeah. Okay. After 1 is popped out, the in degree of 2 is 0. So we're gonna push 2, and 2 has an outgoing edge to 3, so it's gonna be 0. So we're gonna push 3, and after 3 is pushed inside, it has an outgoing edge to 5, so we're gonna cancel it out, and it's gonna have 0. Pop, pop. Okay. Over here we have 5, and after popping 5, we have a 1 here, but we have no zeros that are not visited, so we're gonna stop toposort here, and we have the nodes. Toposort nodes, the order is 0, 8, 11. This one is actually supposed to be here, so wait, let us just put 1, 10, 9, 2, 3, right. This is toposort. Okay. See here that we didn't consider the nodes 4 and 5, because on considering these two nodes, it will form a cycle. So yeah, that pretty much proves the point that the toposort is gonna remove nodes that are part of the cycle, that will form the cycle. It will prevent considering any node that might form a loop. I think that's pretty much clear on how we solved it. So let us see it with this example only. So, which one was this? Okay. 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 Let us take this example and see if our approach is gonna work. Okay. Hmm. Node 0 goes to 1, 2, 3, 4. Node 1 goes to 1, 2. 2 goes to 3, 4. Node 3 goes to 0, 4. And node 4 has no outgoing, so gonna be a terminal node. Okay, let us draw a graph for this. Node 0, node 1, node 2, node 3, and node 4. 0 can go to 1, can go to 2, can go to 3, can go to 4. 1 has an edge to 2, 1 has an edge to itself. 2 has an edge to 3, and 4. Three has an edge to 4, and 0. Okay. So if you're gonna take in-degree matrix, so it's gonna be, let's take it 1, 0, 1, 2, 3, 4. 0 has 1 in degree, which is from 3. 1 has 1, 2, okay. 2, 3 has 1, 2, 2, and 3 has in degree of 2, and 4 has in degree of 1, 2, 3. Technically, this has no nodes of in degree 0. So I would say only 4 is a node which is a safe node, as it has no outgoing edges. If we try to code this up, then sorry, never mind. Okay. So let us create n degree matrix of size of n nodes, having n nodes, I would say, and let us initialize them to 0. And now for int I is equal to 0, I is less than graph dot size r plus plus. What we're gonna do is for auto IP, I'm gonna add increase in degree of the vertices. This pretty much, this block pretty much gives us in degree initialization. So now what are we gonna do? Let us initialize a queue I just got a thought that maybe here, instead of doing it like this, why don't we change the direction so that the terminal nodes has a degree of 0. What I mean is, for suppose if we have this graph, then let us consider it as 0, 1, 2 and 3. Why don't we reverse the direction so that instead of an edge from 3 to 4, it's gonna be edge from 4 to 3, 4 to 2, 4 to 0, um, okay, so this pretty much sums it up. If you take integrity of this, it's gonna be on 0, 1, 2, 3, 4. Then integrity of 4 is gonna be 0. Integrity of 1 is gonna be 1, 2, 3. Integrity of 1 is gonna be 2. Integrity of 2 is gonna be again 2. Integrity of 3 is gonna be 2. So here if we apply topo sort, then first we're gonna push okay, first we're gonna push node 4. On pushing node 4, on popping out node 4, we're gonna decrease the integrity of 0, integrity of 2 and integrity of 3. But we have no nodes with integrity of 0 that's not visited. So here topo sort result is gonna be 4. That is, instead of here looking for if it's a terminal node or not, it would be more efficient if we reverse the connections and then apply topo sort. Okay, so coming back to the code, what we'll do is vector and reverse graph graph dot size okay, so we initialize a reverse graphs so when I is equal to 0, I is less than graph dot size I plus plus push back I. That should work for this block, should work for reversing the connections. And now after initializing the queue, what we wanna do is insert all wait, reverse graph. Okay, this should work. Okay, so now after inserting, what are we gonna do is int I is equal to we're gonna push all the nodes that's in degree is 0. And degree dot size I plus plus is equal to 0. Q dot push of I. Okay. Now let's perform topo sort. While Q is not empty, its node is equal to P dot from, popping it out from Q. For auto, okay. Auto artery from this graph node in degree of I think minus if in degree of 0 Q dot push I2. This should work fine for topo sort. Okay, here let us maintain a vector. Vector ns dot push back node okay. I just hope this works because as far as I look at it, okay, what error did we get? Come on. What error is the signal? but it doesn't make any sense. Okay, sorry. Mm, okay, in degree, she's typo mistakes. Oh yeah, wait. Um, what mistake? Let it dry run. Why did I get a mistake here? So error case. Mm, 1, 3, 4, 5. 2, 4. Okay. So if we try drawing this, then it is supposed to be like, if this is node 1, node, let us, okay, let us start from node 0. Node 0, node 1, node 2, node 3, node 4, node 5. 0 to 1 we have an outgoing edge. 0 to 3 we have an outgoing edge. 0 to 4 we have an outgoing edge. 0 to 5 we have an outgoing edge. 1 to there is no outgoing edge from 1. There is no outgoing edge from 2, no outgoing edge from 3, and there is 4 is, so yeah, okay. From 5 we have one outgoing edge to 2 and one outgoing edge to 4. So if you're gonna reverse this, it's gonna be 0, 1, 2, 3, 4, 5. Okay. In degree, 0, 1, 2, 3, 4. And 5. For 1 the in degree is 4. For 0 the in degree is 4. For 1 the in degree is 0. For 2 the in degree is 0. For 3 the in degree is 0. For 4 in degree is 1. For 5 the in degree is 1. Okay. So if we take a topo sort, first we're gonna insert 1, then 2, then 3, popping it out. After popping it out, do we have an ingoing edge? Yeah. We have outgoing edge, so it's gonna be 3. Then we'll pop out 2. It's gonna be 0. So we're gonna insert 5. We're gonna pop out 3. So it's gonna be 2. I'm gonna pop out 5, 4, pop out, after popping out 4, this is gonna be 1. Okay, wait. This was 4. This got to 3 on 1. And then this got to 2 on 3. This got to 1 on 5. This will get 0 now. That's very good. We already 1 and it's gonna be go to 0. So it is pretty much gonna show, you need to show 0, 1, 2, 3, 4 and 5. And I don't know why it's not showing. We reversed all this. Then there is some mistake here only. You know what? Maybe I should push it here instead of adding it here. But then wait, then we won't have. Let me see. Where would I go wrong? Interesting. Let's check it up why I made it so long. Would I do it wrong? Okay, wait. Isn't that what exactly I wrote? Mm, mm, okay, that's what exactly I did. And here too. It doesn't make sense. That's what I wrote.